I have an alcohol stove problem. Since I learned about them, here are the stoves I have made. I regard it as a harmless, if incendiary, hobby. I've tried all different types and tried out various modifications. I've gravitated towards the classic pressure wall stove, which produces nice burning jets, but have tried various forms of wicking stoves as well. I concluded that the jet burner stove was more efficient in fuel use, but that it was also prone to the danger of spilling when it was knocked over. Of all of the alcohol stoves, the Trangia is the one to beat. Its main advantage is that you can store fuel inside it when not in use. It also comes with a simmer ring, which is hard to imitate for improvised stoves. The whole stove, as sold, weighs in at 110 grams. In order to use the stove properly, it does need a trivet, which is not solved with the stove. However, I have come to the conclusion that the best alcohol stove is the pressure wall stove made from a drinks can. The version I use can be used without a trivet and is free to make using recycled materials. This stove weighs 10 grams and is compact and easy to carry. I won't discuss how to make it here because there are plenty of YouTube videos about the subject. This video is about how to make a can stove more efficient, especially in cold and windy conditions. A factor which greatly improves the efficiency of an alcohol stove is the use of a windshield. This works in two ways. It enables the stove to burn evenly, and it also prevents the cooling of the walls of the vessel being heated. Anything that works will do. This windbreak is made from a cocoa tin with slots cut in the lower wall to allow air to reach the burner. But its disadvantage is it's inflexible and you can't pack it away easily. And so a better solution is to make a semi-folding screen from two beer can walls joined together by tabs. I've also discovered that using a drinks can as the water vessel is extremely effective, and that boil times of 6 minutes for 300 millilitres of water is extremely competitive with conventional stoves and other containers. An empty drinks can is also free, but it does have problems of being difficult to pour from unless you use gloves or use a couple of sticks. You, of course, can't cook using an unmodified drinks can as a container, and that is also a disadvantage. Another factor which seems important for a fast boil is the height of the vessel above the flame. This seems to be between 3/4 and 1 inch. In this arrangement, using a drinks can as the boiler with no trivet, this distance is provided by allowing the flames to run up the sides of the can. This is encouraged by the funneling effect of the windbreak. Recently, I watched a video about heating water in very cold conditions, and it seemed that gas stoves freeze up and alcohol stoves can still keep working however cold it gets. This prompted me to think about the subject of this video, which is to make a system that is guaranteed to work no matter how cold or windy the conditions. I've been thinking about how to make a heat exchanger so that the heat generated by the stove can heat the water. This seems to be one of the principles at work in the jet boil camping gas stove. I realised that I could use a windbreak to channel the heat onto the heat exchanger. The heat exchanger is made up from two Coke can walls which are pleated and joined with tabs. With this construction, when the can is filled with water, it slides down to sit on the top of the stove. The problem with this is it's not the optimum height above the flame. I did think of making tabs on the windbreak walls, but realised the temperature might be too high within the heat exchanger and that these might melt. And so I decided to use a stiff wire. This is the only material not derived from the drinks can in this version of the stove. At the moment it's spring, so the stove can't be tested in cold conditions. However, the first test boiled 300 millilitres of water in under 5 minutes in windy conditions. The heat exchanger offsets some of the advantage of the simple can stove in that it is bulky and somewhat heavier. However, it may well be worth it if you have to absolutely guarantee to boil water no matter what the conditions. A further efficiency afforded by this arrangement is the water can start heating before the stove blooms, which usually takes a minute or two. This wastes usable heat. The boiler with heat exchanger weighs 43 grams. So if weight is a problem, then including the stove, this arrangement at 53 grams is still half the weight of a Trangia stove. Although I wouldn't recommend it, it could be carried disassembled and made up only when needed. I don't think it is very robust, but that problem is somewhat alleviated by the ready availability of the materials needed to refurbish it. Without doing side-by-side testing, it is difficult to prove whether this heat exchanger gives much advantage over a simpler stove and windbreak arrangement. I can only say that on my first tests, I was surprised by how simple and reliable it felt and how fast it brought water up to a rolling boil. I tried this version of the stove and it worked very well, but I noticed that the windscreen wall was very hot. Thinking back to my heat exchanger design, I realised that just as much heat was being conducted to this wall as was being conducted by the boiler, and so I decided to insulate the outer wall. In accordance with my belief that the materials for this should be readily available, I tried surrounding it with corrugated cardboard. This set fire spontaneously, confirming the amount of heat that must be present at the outer wall. There were no flames near this cardboard because I only added it to the upper windscreen wall. Reluctantly, I decided to purchase some carbon felt from Amazon and use that for insulation. That provided the further benefit in that the boiler could be poured by hand. Imagine my dilemma when I found a stove that was simpler to construct and brought water to boil in about 20% less time. Let me construct it for you. I don't know what it's called, so I'm going to name it and wait for somebody to tell me otherwise. This is the capillary seam alcohol stove, or CAPS stove. I'm not sure whether this insulating wall enables the boiler to heat more quickly. It certainly seems to boil in reasonable time and may provide an advantage for the cold conditions this design is intended to work in. Because it is designed in response to various videos I have seen in which the real advantage of an alcohol stove is that it doesn't fail in extreme cold, these conditions are increasingly rare because of global warming in the UK. I would love someone to test it where cold is an important problem. So if you see this video and have some time on your hands, have a go at making one and try it out for yourself.